Hello everyone. We are now in topic 4.1 of our basic calculus subject, which talks about different types of discontinuities. The competency. At the end of this session, you are expected to illustrate different types of discontinuity: whole or removable, jump or essential, asymptotic or infinite. In topic 1.2, it was emphasized that the value of limit of f of x as x approaches c may be distinct from the value of the function itself at x equals c. Recall that a limit may be evaluated at values which are not in the domain of f of x. In topics 3.1 to 3.2, we learned that when limit of f of x as x approaches c and f of c are equal, f of x is said to be continuous at c. Otherwise, it is said to be discontinuous at c. We will revisit the instances when limit of f of x as x approaches c and f of c have an equal or different values. These instances of inequality and therefore discontinuity are very interesting to study. So in this topic, we will be focusing on these different instances. Now let us consider the functions g of x, h of x, and j of x, where g of x is equal to 3x squared minus 4x plus 1 all over x minus 1 if x is not equal to 1, and 1 if x equals 1. H of x is equal to x plus 1 if x is less than 4, and quantity x minus 4 squared plus 3 if x is greater than or equal to 4. Then j of x is equal to 1 over x at when x is not equal to 0. We will examine this for continuity at the respective values 1, 4, 0. That means for g of x, we are going to use x equals 1. For h of x, we are going to use x equals 4, and j of x when x equals 0. Okay, so investigating the limit of g of x as x approaches 1. So notice that g of x is similar to 3x squared minus 4x plus 1 all over x minus 1 as x approaches 1, in which the numerator can be factored out. So factoring the numerator, we have 3x and x for 3x squared, and 1 can be factored as negative 1 and negative 1 all over x minus 1. So in this case, we can cancel out x minus 1 and investigating the limit of 3x minus 1 as x approaching 1. So this will give us a value of 3 times 1 minus 1, which is similar to 3 minus 1 or equal to 2. And that's why we have 2 here. And evaluating g of 1 is equal to 1. So it is very clear that when x is equal to 1 using this function, the denominator is undefined or is equal to 0. That will make the function undefined. For the second one, we have h of x is the same as x plus 1 if x is less than 4, and quantity x minus 4 squared plus 3 if x is greater than or equal to 4. Investigating the limit of f of x, h of x as x approaches 4. So to investigate this one, we are going to find first the limit of h of x as x approaching 4 from the left. From the left, we are going to evaluate this x plus 1 because this one is 4x is less than 4. So 4 plus 1 equals 5. Okay. And the limit of h of x as x approaches 4 from the right. So we are going to use the second one, replacing x with 4. That would be 4 minus 4 squared plus 3 is equal to 0 plus 3 or 3. So since 5 and 3 are not equal, therefore we can say that the limit of h of x as x approaches 4 does not exist. Okay, so morning does not exist here, but if we are going to evaluate h of 4, we are going to use this one because it is for x is greater than or equal to 4. So evaluating, we have 4 minus 4 is 0 plus 3 is equal to 3. So notice that the limit does not exist, but it has a value for h of 4, it has a value that is equal to 3. Okay, for the third one, evaluating the limit of j of x as x approaching 0 from the right, does not exist si dyan, no? Kaya inigabot niya sa 0, undefined si dyan. And then, from the left pod, inigabot po niya sa 0, undefined si dyan. So that's why the limit of j of x as x approaching 0 does not exist, and f of 0 also does not exist. All of the functions notice that all of these functions are discontinuous at the given values. So we will be discussing more of this discontinuity in this topic. Okay, so the first type of discontinuity is what we call as the removable discontinuity. A function f of x is said to have a removable discontinuity at x equals c if limit of f of x as x approaches c exists. That means the limit of f of x as x approaches c from the left and from the right are equal. And b, either f of c does not exist or f of c is not equal to the limit of f of x as x approaches c. It is said to be removable because the discontinuity may be removed by redefining f of c so that it will be equal to limit of f of x as x approaches c. In other words, if limit of f of x as x approaches c is equal to L, a removable discontinuity is remedied by redefinition. That means let all f of c be equal to L. So ato ang i-redefine para ma-remove ang discontinuity. Okay, so let us use the previous example we have. The g of x is equal to 3x squared minus 4x plus 1 all over x minus 1 if x is not equal to 1 and 1 if x equals 1. So if we are going to illustrate the graph of that function g of x, notice that mao ni ang situation. It is undefined at x equals 1, so that's why hollow ni din he. And 1 if x equals 1, so 1 eh. So na hollow and then naadire ang value. Okay, but we can redefine it. Pwede na nato i-redefine. Instead of saying 1 if x equals 1, pwede na to himuog 2 if x equals 1. So, ang pag-redefine nato sa function, that means atong ibalhin, redefine nato or mabalhin ang istorya instead nga mabangag matapakan aron maghimo tayong istorya para matapakan another statement nga matapakan nato ang bangag sa function. So mo na siyang kay naghimo naman ta instead of 1 if x equals 1, dili man ta to atong himong 2 if x equals 1. So this is now ang bag-o nga from here gitapak na dito. So pwede silbi na to i-transfer by redefining the statement na as a function. So that is why the discontinuity is called a removable one. And sometimes kani siya nga situation is what we call as whole discontinuity instead of removable discontinuity. Okay? The second discontinuity is what we call as the essential discontinuity. A function f of x is said to have an essential discontinuity at x equals c if limit of f of x as x approaches c does not exist. When we talk about essential discontinuity, there are two cases involved. The first case is if for a function f of x, limit of f of x as x approaches c does not exist because the limits from the left and from the right of x equals c both exist, but they are not equal. That is, the limit of f of x as x approaches c from the left is L, and the limit of f of x as x approaches c from the right is equal to m. So L is not equal to m. So we can say that f is said to have a jump essential discontinuity at x equals c. So kaninga case is what we call as jump essential discontinuity. Okay, so let us use the example we have in our previous slide, that h of x is equal to x plus 1 if x is less than 4, and quantity x minus 4 squared plus 3 if x is greater than or equal to 4. So we learned that from the left of 4, the limit of h of x as x approaches 4 from the left is approaching to 5. So motan kani sa atong graph, and the limit of h of x as x approaching 4 from the right, so from the right di as just a 3 silbi mo na nga example nga wa nag-abot, mura ni sa uyab nga nagsabot og adto mag-date sa plaza pero wa kasabot asang plazaha, no? Ang usa des plaza sa Sugod, ang usa to as plaza sa SLSU, mo nang wa nag-abot sila, so wa nahitabo sa date kay wa nagkatuod. Okay, so yan na, no? Sige, so mo ni siya ang gitawag og jump essential discontinuity. Ang from the left ug ang from the right are not equal. Okay, so this graph confirms that the discontinuity of h of x at x equals 4 is certainly not removable. So di na to pwede ma-redefine ang atong function. Okay, so kaya nahitabo luksoon kadyo para maabot dire. Wala gitawag og jump, no? Wala ilahanan. Okay, so nasabtan na ni. Okay, so let's proceed to case number 2. If a function f of x is such that limit of f of x as x approaches c does not exist because either first one, the limit of f of x as x approaches c from the left is equal to positive infinity, or the limit of f of x as x approaching c from the left is negative infinity, or the limit of f of x as x approaching c from the right is positive infinity, or the limit of f of x as x approaching c from the right is negative infinity, then f of c is said to have an infinite discontinuity at x equals c. Okay, so for this discontinuity, we are going to use the previous example we have, that is j of x is equal to 1 over x. So notice that the limit of j of x as x approaching 0 from the left is equal to negative infinity. and the limit of kani approaching si sa zero from the left padong pud siya ngadto sa negative infinity, whereas the limit of j of x has x approaching 0 from the right, so adto po siya sa positive infinity. So tungod ani ang limit of j of x as x approaching 0 does not exist. No. So kani nga situation, we call that one as we have the infinite essential discontinuity. Okay, so to illustrate the three different discontinuities, we have to examine the situation if the limit of f of x as x approaching c exists. So imong identify no ning exist pa or wa. So kung ning exist, imo na pong i-ask, imong kaugalingon kung ang limit of f of x as x approaches c is equal ba sa value sa f of c. If equal, so we can say that f is continuous at c. Kung dili, meaning ang function has a removable discontinuity at c. So removable but discontinuity will happen. Okay? Discontinuous siya pero removable lamang. So again, dere, kung no gani, so ang imong buhaton is do the one-sided limits exist but are unequal. And then if no gani, then f has infinite essential discontinuity. If yes, meaning it has a jump essential discontinuity. So I hope these three types of discontinuity naklaro unta ninyo sa atong discussion today. Okay, so if you have some questions regarding our lesson, just PM me or chat me anytime so that makahelp ko in understanding our different topics. Thank you everyone for watching. God bless you always. Bye-bye.